Hey everyone, and welcome to This Explainer. I'm stepping in as your mentor today because we're going to break down some absolutely crucial insights from a recent Springer textbook on software design. We're looking at what it really means to build software in the era of large language models, and more importantly, how you can position yourselves for incredible success. Because look, the way we build software is literally changing overnight, and the engineers who adapt now are going to be the ones leading the industry.
Okay, so here's our game plan to future-proof your careers. We're covering 1. The vibe coding era. 2. AI's hidden architectural costs. 3. Owning the business logic. 4. The new engineering formula. And finally, 5. Your future engineering skill set. Let's jump right into it.
Section 1. The vibe coding era, a paradigm shift. Let's kick things off by addressing the massive elephant in the room that I know pretty much every computer science student is sweating right now.
I hear this exact question in lecture halls all the time. If AI can generate thousands of lines of perfectly working code in, 3 seconds? Does anyone actually still need to think about software design? I mean, are your degrees basically obsolete before you even graduate? It's a completely valid fear when you watch a machine do your homework in the blink of an eye. But the short, confident answer? Yes. You absolutely still need to think about design. Actually, it's more relevant now than it ever has been. To really grasp why, we need to look at what people are calling vibe coding. Basically, this is using high-level natural language instructions to just prompt an AI into generating entire features or even full applications. We've all seen it, right? Code generation has become incredibly fast and undeniably cheap. You can spin up a script or bootstrap a UI in seconds just by asking an AI to handle it.
What we're experiencing is a massive paradigm shift away from traditional code craftsmanship. The days of acting like a bricklayer, meticulously writing the perfect for loop or memorizing syntax, those days are fading fast. Instead, your future lies in system orchestration. Your real value is no longer in laying the bricks. It's in managing complex data flows, integrating all these disparate APIs, and acting as the architect of the entire structural blueprint.
Which brings us to Section 2, AI's hidden architectural costs, the big ball of mud. We need to talk about the very real dangers of blindly trusting those rapid AI outputs without human oversight. So here is the trap of the push-button coder. AI is amazing at local optimizations, like it will write a single function flawlessly, but it completely falls apart at global architecture. Why? Well, because an LLM relies on predicting the next statistically probable token. It doesn't actually understand your specific business logic, so it creates these hallucinated structural choices. You push a button and bam, you've instantly generated a massive amount of technical debt. Without your strict boundaries, your codebase just evolves into this tangled big ball of mud that no human and eventually no AI can actually reason about. Think of it like this. AI is an ultra-fast line cook working at 10 times the normal speed. But you're the master chef. You still absolutely need the master chef's palate to ensure the final dish actually comes together perfectly. The AI is just doing the prep work. You have to understand deep design principles, like checking if the AI just violated the single responsibility principle to audit that meal. The AI doesn't inherently know what sustainable design looks like. You have to provide the vision. Let's move to Section 3, owning the business logic, beyond the prototype. This is all about the vital importance of human ownership over complex systems. When you look at the software development lifecycle today, you have to draw a hard line between exploratory prototypes and final products. Vibe coding? It's invaluable for quick direction or generating boilerplate, but for final products that house complex business logic, strictly managing or even writing that code yourself is often the only way to take full ownership. You have to truly comprehend the maintenance costs and those weird little edge cases. AI is fantastic for exploring ideas for sure, but you absolutely must own the parts that require deep, nuanced thinking.
Because guys, a production system is so much more than just a pile of code. We're talking about continuous deployment pipelines, complex database schemas, caching layers, strict security compliance, cloud infrastructure, the whole shebang. An AI literally cannot solve a massive traffic bottleneck just by writing a faster sorting algorithm. Deciding exactly where that bottleneck is going to happen and how to distribute the load requires your structural blueprint for all those non-functional requirements. And this brings us to a harsh, core economic truth about your future careers. We made writing code cheap, but understanding that code has stayed exactly as expensive as it has always been.
Reading and mentally modeling complex systems is hard, cognitive work. The developers who thrive won't be the ones generating the most lines of code. Never, ever confuse the fact that the tests passed with the reality that a human actually understands what this module does.
All right, Section 4. The new engineering formula, calculating your value. Let's look at the actual equation you need to succeed in the modern workforce. To succeed, you need a completely new mental model. Ready? Your value as an engineer now equals your domain expertise multiplied by your system architecture skills multiplied by your AI prompting efficiency. All three of these components are non-negotiable. You have to deeply understand the business problem, you need to know how to structure the solution, and you need to know how to efficiently drive the AI to build the pieces.
But let me warn you bluntly right now. If your system design skill is a 0, multiplying it by incredibly fast AI code generation still leaves your total value at exactly 0. An AI coding agent is basically just an incredibly fancy autocomplete. If you lean on it as a crutch because you don't actually understand the underlying domain, you're asking for a disaster when the system inevitably scales or breaks.
Section 5. Your future engineering skill set, the survival guide. Let's transition to the highly structured, actionable skills you need to start practicing immediately. This paradigm shift means you need a completely upgraded professional toolkit. The old skills you've been learning, they're evolving. Instead of traditional unit testing where you painstakingly check your own logic, you're now doing black box measuring to verify what the AI spit out. Instead of basic code organization, you're thinking about macro modularity. And traditional requirement gathering, that is evolving directly into architectural prompting.
So this leaves us with a modern 4-step workflow. 1. Architectural prompt engineering. 2. Measuring black box outputs. 3. Macro modularity and system orchestration. And 4. Managing the technical debt of the unknown. Let's actually unpack a couple of these so you can see what a day in the life of a modern engineer really looks like. First up, architectural prompt engineering. A good prompt isn't just asking an AI for a new feature, it's about establishing strict technical guardrails, setting hard constraints and boundary conditions. For example, explicitly demanding that the generated module prioritize low latency over memory usage because of a specific hardware limit. You have to provide precise context and establish design practices so the AI knows exactly how to behave within your larger architecture.
Next is black box measuring and modularity. Testing isn't just checking logic you wrote anymore. It's empirically verifying the fitness of code you didn't manually write. You're going to be building automated guardrail scripts to test AI outputs for security flaws before they ever hit production. And modularity? That's all about risk isolation, making sure the whole system survives when one AI-generated black box module inevitably breaks.
So here's the ultimate takeaway. Software design is not dead, it's actually been elevated. Leave the syntax to the machines. I want you to view this as a massive, empowering shift. AI is a huge promotion for your careers, not a layoff. Instead of spending hours typing out exactly how to implement a database connection, you get to spend your time deciding which data pattern fits the business and orchestrating the AI to execute your high-level vision.
I want to leave you with one final, provocative question to think about today. Are you training to be a coder or a software architect? The future belongs to the engineers who think deeply about structures, business boundaries, and system interactions. Keep focusing heavily on those deep design thinking classes, because your architectural mind, that is the one thing the AI literally cannot replace.